Manufacturers often spend millions on high-end robotic arms and software suites, expecting these tools to automatically forge a smart factory. Instead, they plug the machines in and watch their defective product rates rise and their assembly lines jam. Bill Gates observed a strict rule about corporate automation. When you apply new technology to an inefficient operation, you do not fix the process, you magnify the inefficiency. This equation illustrates the mathematical reality. A broken workflow with a value of 0 multiplied by a flawless AI system still equals 0. Spending millions on automation without first repairing the physical workflow creates a faster, more expensive method for depleting capital. For decades, the Toyota production system set the global standard for eliminating waste. Teams achieved lean manufacturing through strict physical discipline, tracking metrics on whiteboards and passing paper cards down the line. But as supply chains scale across continents, those analog tools reveal severe vulnerabilities. Physical cards cannot cross borders instantly, handwritten data invites human entry errors, and most critically, paper systems suffer from severe information delay. This delay creates the latency trap. If a worker spots a defect on the line, but it takes 4 hours for that handwritten note to travel from a clipboard to the plant manager's desk, the factory has spent 4 uninterrupted hours producing garbage. Analog lean tools are brilliant in their design, but they are entirely too slow to survive against modern competitors using real-time data networks. The solution is digital Kaizen. This is the practice of attaching a digital nervous system to your existing physical tools. You keep the human worker at the absolute center of problem solving, but you give them the speed of a machine. Compare the old whiteboard updated by hand every hour to an inexpensive IoT sensor at the end of a conveyor belt. It feeds live cycle times to a digital dashboard and pings the manager's phone the precise second a machine falls behind schedule. Compare physical inventory cards that get dropped, lost, or delayed in transit to e-Kanban RFID scanners. A worker scans an empty bin, and the supply chain order triggers at a partner facility halfway across the globe, eliminating traditional administrative lag. Compare engineers machining custom metal brackets to prevent workers from loading parts backward to high-speed AI machine vision cameras. The camera scans components on the fly, spots microscopic flaws in milliseconds, and autonomously rejects the bad parts. Compare replacing expensive machine parts on a rigid calendar schedule to predictive maintenance. A tiny vibration sensor attached to a motor alerts technicians that a bearing is failing days before the metal actually breaks. Digital Kaizen combines the discipline of the physical factory floor with the immediate responsiveness and scale of cloud computing. Consider the Scion textile weaving factory. Their floor housed 50 physical looms, and whenever a thread snapped, a worker had to manually write down the downtime on a paper clipboard. Old system. A thread breaks, but the manager sees the log 24 hours later, after defective fabric ships. The fix? Inexpensive IoT sensors. The gap collapses to 0. Instant cloud alerts dispatch maintenance immediately, spiking efficiency from 60 to 82%. The factory produced the exact same textiles using the exact same machines. They simply eliminated the latency between a physical problem and human awareness. To successfully upgrade your own floor, you must follow strict guidelines. Rule 1. Do not digitize waste. You have to streamline a broken physical process before you write a single check for software. Next, address the psychology of your workforce. If employees believe you are installing sensors to track their bathroom breaks, they will sabotage the hardware. You must clearly frame the technology as a tool designed to make their daily tasks easier. Never attempt a factory-wide digital overhaul on day 1. Start small. Pick a single problematic machine, run an IoT pilot program to prove the system's value, and only scale up once the concept works. Building an intelligent factory is a challenge of human behavior and process management. The IT infrastructure comes second. Klaus Schwab, founder of the World Economic Forum, outlined the harsh economic reality of the Fourth Industrial Revolution. He warned that in the current business landscape, velocity has replaced scale as the primary driver of market dominance. Companies that move with speed will displace those that remain stagnant. This equation maps the exact path forward. A lean process, driven by problem-solving workers, multiplied by digital technology, results in a true smart factory. Tech is merely the multiplier you apply to your human baseline. If your physical processes and human ingenuity sit at zero, multiplying them by the world's most advanced technology only ensures you have automated your own collapse.